When is a model steam engine not worth rebuilding? Part 4. Despite mentioning to the customer that in my opinion this engine was not worth rebuilding owing to the time and subsequent cost involved, he insisted that I do so, and a lot of time and effort was needed to make this happen. In the first part of this compilation, I'm refitting the crankshaft into the main bearings. This is a zero tolerance operation. I stress in the video how important it is to get the crankshaft right before you fit anything else. The crankshaft is singularly the most important part on a steam engine. If this is not right, then nothing else above the crankshaft will be right. Most crankshafts have a 3-bearing system, as you can see here. Some have a 5-bearing system, which is better. But in this case we've stuck with 3 bearings, centre and one at the left and one at the right. So here you see me placing the crankshaft loosely in position and having a look how it sits in the bearings. It seems to sit very well. Someone at some stage has machined too much off the end caps, so it will need considerable shimming to make it work. The main bearing caps have to be a very solid, stable fit on the rest of the main bearing. And the only way to do this successfully is to use spacers or shims in between the top cap and the main bearing. If the top cap is allowed to clamp the crankshaft in position, severe damage will occur. If the crankshaft is a tight fit in the bearings, what's going to happen is the bearings are going to overheat. And if the bearings overheat, the lubricating properties of the oil that you're using will be cancelled out, and you will get metal-to-metal contact, followed by scoring of both surfaces. That is, the surface of the crankshaft and the surface of the bearing. This will ruin both of them. Then you really will have to do some work to fix it. Fitting this crankshaft is a real test of patience. You need lots of patience for this. And be warned, if you run out of patience and think, oh, that'll do, it's a bit tight but it'll be okay, it'll run in. Not a good idea. It will run in, but at the expense of metal removal from either the bearing caps or from the crankshaft itself. Alternatively, if you think that'll do and the bearing is too slack, what will happen is the engine will rattle and it will make knocking noises when you don't want it to. Always work on a steam engine from the bottom upwards. If the crankshaft is not right, nothing above the crankshaft is going to be right either. After finding the correct combination of shims, the next thing to do is to oil the crankshaft before fitting the top cap permanently. Here you see me tightening down the top cap for the first time on a lubricated crankshaft. And it's a little bit tight. It's not quite as smooth as I would like it to be. So off comes the top cap once again, and I'll put another shim in there and see what happens. This is not like doing a car engine. With a car engine, with the main bearings on a car engine, you would have to use a torque wrench and really tighten them up hard. That's because the bearings on a car engine are carried in a very hard metal support, whereas on a steam engine, generally speaking, the bearings are manufactured from the bearing material, in this case it's gunmetal. So if you do over-tighten the top cap, you are likely to distort the entire bearing and will probably make the crankshaft feel tight when it isn't. And here I over-tightened the bearing cap to illustrate the point, and if I just back off very slightly, the crankshaft spins beautifully, so much so that I can turn it round and do the other end. As you can see by the video, even at 10 times speed, this cap is coming on and off like a yo-yo. What I tend to do if I'm making shims is I make them like I'm showing on the video. Instead of it being a piece of metal with a hole in it, which means that you have to take off the entire bearing cap, I cut a slot in my shims, which means that you can just lift the cap, thread the shim underneath and tighten it down. These shims that I'm making are very, very fine and just put the icing on the cake. As you can see clearly here on the video, the holes in the mounting lugs are not in the right place, and to compound the problem, the mounting lugs are not in the right place either. The original base casting pattern must have gone a bit wrong. I can't do anything about that, but I can do something about the position of the holes. So I'm going to re-drill the holes, but first I need to plug up the existing holes. This is a cast iron base plate, so I have some cast iron here that I'm going to machine to fit in the holes. The smallest diameter cast iron I could actually get was 1 inch, so I'm going to machine it down to 5/16 of an inch diameter. This is a simple plain turning job. It'll make lots of swarf, but eventually we'll end up with 4 pieces 5/16 of an inch in diameter by 1 inch long. I don't wish to be too long-winded on this because this is really the rebuild of an engine, but if you want any more details if you're a beginner, please have a look at the Model Engineering for Beginners video that covers repairing common mistakes. And a common mistake is to drill a hole in the wrong place. Sometimes you can scrap the part and just make a new part, but I can't really scrap this base plate because there's no way I can get a replacement. So I'm having to do it the hard way, which is to turn down a really nice piece of cast iron which is 1 inch diameter down to 5/16 of an inch. It is important to use the same material if you're plugging a hole. For instance, do not use steel in a cast iron bed plate because when you come to re-drill, the drill will wander into the softer cast iron. I need to end up with 4 pieces of cast iron, 1 inch long and 5/16 of an inch in diameter. Here you see me machining off the centre because I don't want a centre hole left in the work. I just need 4 little barrels of cast iron to plug the holes. These are not a tight fit in the hole. I'm using Loctite 603 to hold them in position. Nor are they a rattle fit. Almost like a piston fit is what's required. And then tap the piece into place using a hammer. But go steady, you don't want to smash the base casting. And if it's too tight, you will smash the base casting, so be warned. You need to put just enough pressure on and not too much. After the Loctite 603 has fully cured, I'm using a file to clean the top surface. And here you see me using a washer to help me find the centre of the lugs. I can't be too precise on this part because none of the lugs are the same shape. And as I mentioned earlier, even the lugs aren't all in the right place. Following the centre pop from the centre punch, I went through with a quarter drill first, then opened up the 1/4 inch hole to 5/16. A good thing about that is if the 1/4 of an inch diameter hole was in slightly the wrong place, I could file it round, but I try not to bodge like this, I try and get it right in the first place. Quite unlike the original builder of this engine, who seemed to drill holes just where he felt like drilling them at any given time. The holes are now in the right place. You can see how far they were originally out. When it gets bolted down to the stand, all the bolts will be in the middle of the lugs, and it looks much better. And that is it for this quite informative episode. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.